Dear students, welcome to our Maths Teacher YouTube channel. Today you are going to learn about equations in grade 11. First lesson, simultaneous equations with fractional coefficients. There are two methods to solve these types of simultaneous equations. The first method, solving equations by converting fractions into integers. The second method, solving equations by substitution. You know that simultaneous equations having fractional coefficients are known as simultaneous equations with fractional coefficients. The first method, solving equations by converting fractions into integers. You are given two equations. First, you have to name the two equations as first and second. According to this method, the LCM of the denominators of each fraction in each of the equations have to be found separately to convert fractional coefficients into integral coefficients. The LCM of both of these equations is 12. Therefore, each and every terms of each equations have to be multiplied by 12. First equation is multiplied by 12. You have to multiply each and every terms by 12. You can see that some terms are get cancelled. Then it is converted into an equation 8x minus 3y equals 24. Let's name it as the third equation. Then we multiply the second equation by 12. Each and every terms have to be multiplied by 12. After simplified, the equation 2x plus 9y equals 84 is obtained. Let's name it as the fourth equation. The two simultaneous equations 3 and 4 involving only integers are solved instead of first and second equations. The coefficient of x and y in two of these equations are not equal. Hence, the fourth equation is multiplied by 4 to make the coefficients equal in x. If you want, you can multiply the third equation by 3 to make the coefficients equal in y. Now let's multiply the fourth equation by 4. That is 8x plus 36y equals 336. Let's name that equation as the fifth equation. Now you can see that in the equations third and fifth, the coefficients of x are equal and they are in same signs. So you can subtract these two equations. Subtract the third equation from the fifth equation. If not, subtract the fifth equation from the third equation. Here I have subtracted the third equation from the fifth equation. There you have to place brackets when subtracting. Then remove the brackets by multiplying by the negative sign. That is negative 8x, negative into negative positive, so positive 3y. You can see that 8x is get cancelled. Now simplify the like terms. 36y plus 3y, that is 39y equals 312. To find the value of y, you have to divide both sides by 39. Then the value of y is 8. Now the value of y is substituted in any of the above equations to find the value of x. I substitute the value of y in the third equation. 8x minus 3y equals 24. 8x minus 3 into 8 equals 24. 3 into 8 is 24 and negative 24 is removed from left side. Then 8x equals 24 plus 24, that is 48. So 8x equals 48. To make x the subject, divide both sides by 8. So the value is 6. Then the value of x is 6. So the solutions of these two equations are x equals 6 and y equals 8. We can verify that the solution is correct by substituting the answers in the original equations. Let's substitute the values x equals 6 and y equals 8 in the first two equations. Consider the first equation. We substitute the values of x and y for the expression in the left hand side. After simplifying them, you can see that 4 minus 2 equals 2, that is equal to right side of the given equation. That means left hand side is equal to the right hand side. Now let's substitute the same values in the second equations too. After simplified, you can see that is 1 plus 6, it is 7. It is equal to the right hand side of the second equation. That means left hand side is equal to the right hand side. Therefore, we have the correct answer x equals 6 and y equals 8. So, x equals 6 and y equals 8 satisfy the equations. Hence, the solution is correct. Let's see the second method. Solving equations by substitution. Let's consider the same example we discussed earlier. First, you have to name the two equations as first and second. In this method, one of the unknown terms is made as the subject in one of these two equations and the value of it is substituted in the other equation. Let's make x the subject in the first equation. Then 2/3 x equals 2 plus 1/4 y. I removed 1/4 y from left hand side. Now you need to make x the subject. First you have to remove 3 from left hand side. For that, multiply both sides by 3. Then 2x equals 3 into 2 plus 1/4 y. Now remove the brackets by multiplying by 3. 3 into 2, 6. 3 into 1/4 y, that is 3/4 y. To make x the subject, now it is needed to remove 2 from left hand side. For that, divide both sides by 2. You have to divide each and every terms by 2. Then x equals 6 over 2 plus 3y over 4 into 2. 6 divided by 2, that is 3, plus 3y 8th. If not, 3/8y. Let's name that equation as the third equation. Now, the value of x is substituted in the second equation. 1/6 x plus 3/4 y equals 7. We can replace x by 3 plus 3/8 y. Then 1/6 into 3 plus 3/8 y plus 3/4 y equals 7. Now remove the brackets by multiplying by 1/6. 1/6 into 3, that is 1/2. 1/6 into 3/8y, that is y over 16, plus 3y over 4 equals 7. You can take 1/2 to the right hand side and make the denominators equal in the algebraic fractions in the left hand side. So you have to multiply 3y over 4 by 4, that is 12y over 16th. In right hand side, 7 minus 1/2, that is 6.5. Here, if you want, you can multiply all the terms by the LCM of the denominators in these terms. I have not used that method here. Then, you can see that in the left hand side, denominators are equal. Let's simplify the numerators. Y plus 12y, that is 13y. 13y over 16 equal 13 over 2. We have converted the mixed number 6.5 into an improper fraction. To find the value of y, first you have to remove 16. For that, multiply both sides by 16. Then, to remove 13, divide both sides by 13. After simplified, the value of y is 8. Now let's substitute the value of y in the third equation. That is x equals 3 plus 3/8y. Now y is replaced by 8. After simplified, the value of x is 6. So the solutions are x equals 6 and y equals 8. We have obtained the same solutions as in the first method. We can verify that the solution is correct by substituting the answers in the original equations. But I am not taking a time to do it here as we done it in the first method. Solving by constructing a pair of simultaneous equations. Here you have to construct a pair of simultaneous equations by yourselves and solve it too. Let's see such an example. A mother divided 1/3 of her land to her son and 1/4 to her daughter. Their father also divided his land among them as 1/2 of the land to the son and 1/5 to the daughter. The total area of the land was received by son from his parents is 140 perch. If the area of the land received by daughter from her father is 10 perch greater than the area of the land received from her mother, find separately the areas of the lands initially had by mother and father. Let's assume the area of mother's land as A perch and the area of father's land as B perch. First, it's better to write the given data. According to it, the son has got an area of 1/3 A and 1/2 B from his parents, and the daughter has got 1/4 A and 1/5 B from her parents. In this problem, it is given that the total area of the land was received by son from his parents is 140 perch. An equation can be constructed using that. That is 1/3 A plus 1/2 B equals 140. Yet, it gives another data. That is, the area of the land received by daughter from her father is 10 perch greater than the area of the land received from her mother. 10 perch means the difference of the areas received by daughter from her parents. The other equation can be constructed by using it. that is 1/5 b minus 1/4 a equals 10. First, you have to name the two equations as first and second. Then, find the LCM of the denominators of each of these equations. In the first equation, the LCM is 6. In the second equation, the LCM is 20. Now, you have to multiply the first equation by 6 and the second equation by 20. Now, let's multiply the first equation by 6. You have to multiply all the terms by 6. You can see that some terms get cancelled. Then, we have the equation 2a plus 3b equals 840. Let's name it as third equation. Now multiply the second equation by 20. There also some terms get cancelled. Then we have the equation 4b minus 5a equals 200. Let's name it as fourth equation. Now, in these two equations, third and fourth, you can see that the coefficients of a are not equal, as well as the coefficients of b also are not equal. So, you have to make the coefficients equal to find the values of a and b. Let's make the coefficients equal in a. For that, we multiply the third equation by 5. That is 10a plus 15b equals 4200. The fourth equation is multiplied by 2. That is 8b minus 10a equals 400. Let's name them as fifth and sixth equations. Now you can see that in these two equations, the coefficients are equal and they are in different signs. Therefore, you have to add these two equations. Let's add the two equations fifth and sixth. You can see that 10a is get cancelled. Now simplify the like terms. That is 23b. 23b equals 4600. To find the value of b, divide both sides by 23. Then the value of b is equal to 200. Now you can find the value of a by using the value of b. Let's substitute the value of b in the third equation. 2a plus 3 into 200 equals 840. 3 into 200, that is 600. Then take 600 to the right hand side. Then 2a equals 840 minus 600. That is 2a equals 240. To make a the subject, divide both sides by 2. Then the value of a is 120. Now you have obtained the solutions. A equals 120 and b equals 200. We can verify that the solution is correct by substituting the answers in the original equations. I am not going to do it here. Therefore, the area of mother's land is 120 perch and the area of father's land is 200 perch. I think now you have understood how to solve simultaneous equations with fractional coefficients. You are given a homework. Write answers for the exercise 13.1 in the textbook. The second lesson, solving quadratic equations. There are three methods of solving quadratic equations. The first method, solving by factorizing. The second method, solving by completing the square. The third method, solving by using the quadratic formula. The first method, solving quadratic equations by factorizing. Let's remind how to find the solutions, that means roots, of a quadratic equation of the form ax squared plus bx plus c equals 0. You have already learned this in grade 10. First example, find the roots of x squared plus 5x plus 6 equals 0. First, the quadratic expression in the left hand side should be written by factorizing. That is, x plus 3 into x plus 2. I think now you have the ability to factorize the quadratic expression directly. The product of x plus 3 and x plus 2 to be equal to 0, either x plus 3 should be equal to 0 or x plus 2 should be equal to 0. If x plus 3 is 0, that is 0 times x plus 2. That means the result is 0. As well as if x plus 2 is 0, x plus 3 times 0 is 0 too. Now you have to make x the subject of these two simple equations. Then x equals negative 3 or x equals negative 2. Thus, the roots of the equation are x equals negative 3 and x equals negative 2. Let's see another example. Find the roots of 2x squared minus 5x plus 2 equals 0. As in the first example, factorize the quadratic expression in left hand side. Write linear factors of the product of the quadratic term and the constant term to make the middle term, negative 5x. They are negative 4x and negative x. Now you can factorize. Then the factors are x minus 2 and 2x minus 1. That is, x minus 2 into 2x minus 1 equals 0. The product of them to be 0, either x minus 2 equals 0 or 2x minus 1 equals 0. Make x the subject of these two simple equations. Then x equals 2 or 2x equals 1. To find the value of x in the second simple equation, you have to divide both sides by 2. That is, x equals 1/2. Hence, the roots of the equation are x equals 2 and x equals 1/2. Let's look at a more complex example. Find the roots of 2 over x minus 1 plus 3 over x plus 1 equals 1. Here we cannot see the quadratic equation at once. But when we clear the fractions, it can be set up as a quadratic equation. For this, we will consider the LCM of x minus 1 and x plus 1. That is, x minus 1 into x plus 1. Now multiply each and every terms by this LCM. You can see that some terms are get cancelled as there are common factors. Then we get 2 into x plus 1 plus 3 into x minus 1 equals x squared minus 1. Simplify the like terms by removing brackets and taking all the terms to right side to set up as a quadratic equation. That is, x squared minus 5x equals 0. There is a common factor, that is x. So it can be written as x into x minus 5 by factorizing. The product of x and x minus 5 to be 0, either x equals 0 or x minus 5 equals 0. Make x the subject in the simple equation x minus 5 equals 0. That is, x equals 5. Thus, the roots of the equation are x equals 0 and x equals 5. Let's see another example. The product of two consecutive odd numbers is 99. Find the two odd numbers. The odd number pattern is 1, 3, 5, 7, etc. You know that the difference between two consecutive terms in the odd number pattern is 2. Let's assume one odd number as x, then the other odd number should be 2 greater than x, that is x plus 2. In the problem, it is given that the product of two consecutive odd numbers is 99. Hence, the product of x and x plus 2 should be equal to 99. So you can write x into x plus 2 equals 99. The brackets are removed and 99 is taken to the left hand side to set up as a quadratic equation. That is x squared plus 2x minus 99 equals 0. Then factorize the quadratic expression. Then the factors are x plus 11 and x minus 9. The product of x plus 11 and x minus 9 to be 0, either x plus 11 equals 0 or x minus 9 equals 0. Make x the subject of these equations. Then x equals negative 11 or x equals 9. Therefore, the solutions of the equation are x equals negative 11 and x equals 9. But x cannot be a negative value. Hence, x equals 9. Then one number is 9 and the other number is 11, as the other number is taken as x plus 2. Therefore, the two numbers are 9 and 11. You can get the product of 9 and 11 and you can see that it is equal to 99. That means our solution is correct. Here I have to tell you an important fact. If you are given the product of two consecutive odd integers, there are two pairs of solutions. You have to simplify it also using this method. But there we accept the solution of x equals negative 11 too. Then the other odd integer is negative 9. Thus, there are two pairs of solutions. They are 9 and 11 and negative 11 and negative 9. Get the product of negative 11 and negative 9. You can see that that is also 99. I think now you have understood well how to solve quadratic equations by factorizing. You are given a homework. Write answers for the exercise 13.2 in the textbook. I will be back in the next video lesson. Don't forget to subscribe us. Thank you.